This is
I
Arthur
think
again.
what would happen. Hmm.
I've been wanting to share, first of all, that TechShop it has a PDF preview for the document that it's typeset that has an implementation of some of the HyperF features, and they suggest looking kind of like the speech bubbles that you were talking about. That, you know, this has been coming to my mind as I've been listening to you talk. That could be carried further. Um, the other thing, separate, has to do with the horrible things we do to the descriptive markup of the math uh, in order to put it into display math with line breaks, and how in superior math typography we make an effort to align things vertically on the page in such a way as to indicate the level of indentation within, you know, large delimiters that have broken across lines. It is truly horrible, and it
So,
occurs to me that that's not the only problem that's presented to people with vision impairment.
well, that one's not a problem at all,
Okay.
because the artificial or the necessity of a line break is because of a printed page.
Yes.
And the boundaries, and you know, if you get given a mathematical expression that's gone around the corner, as it were, on the printed page or the screen, that's ignored by the screen reader. I've got no idea that that some things are wrapping at times. In the end, I just don't care. So if you think about what happens in HTML when you start to zoom in and the page reflows, you know, does it matter that a word is on the end of line 2 or the beginning of line 3 for the purposes of reading the paragraph? No, it doesn't. It matters when you're quoting the line number of the page that a person made a quote. And other than that, it's immaterial. Equation alignment is not communicated to blind people. It just doesn't happen. We don't get it in Braille, we don't get it in audio, and we don't get it in screen readers. It's just
I take your
the spatial awareness thing is not there, and actually we have the contrary problem that we actually have to teach the students that you line up the equals signs to help the sighted world. You have to actually actively teach that. It's not. Yeah.
Well, I take your point, Jonathan. It occurs to me that it's possible for an author to do this thing, I'm going to call it horrible, where they use artifacts in tech using like the AMS array environment to create something that looks meaningful on the page to the sighted, but if I look into the markup, that the meaning, the semantics have been entirely obscured. So at that point, I say, clearly this is not appropriate for someone with vision impairment. What is to be done? And I don't see a solution in this particular case. So I would call it a difficult problem.
Yeah. So we have this lovely situation, you know, y equals horrible expression, next line, blank equals not quite as horrible, next line, blank equals looking better, next line, blank equals, oh, that's quite readable. That's a construct we use in high school mathematics and beyond. Does the fact that I had to say blank matter for the understanding? No, in a mathematical sense, because the 4 right-hand sides were all just, could have been laid out. Y equals horrible equals not quite so horrible equals starting to look nice equals readable. Because that's what logic, the mathematical logic is doing. We've been forced, if you like, into writing things down the page because of the page or the blackboard or the physical constraints that I think blind people have actually been a little bit immune from, perhaps fortunately.
I think there's something else going on here, which is that a sighted person can very often look at 2 things and fairly quickly spot the differences. And so when we sort of got this complicated expression and an integral and stuff or whatever, and we do a transformation inside the complicated expression, the sighted person can very quickly see, they've made this change in this part of the expression, everything else is the same. And so on through, whereas the blind person doesn't have a way of seeing at a glance, that what they've done is that they've simplified the fraction. And in a sense, that was what I was talking about with my x plus y plus z example. I could have written x equals the whole big thing and then work through it step by step by step and then cancel step by step by step. And it's completely opaque and it's completely unreadable and gives no insight into what's happening. And it's also quite unmemorable.
So one of the documents I remember reading when I was a graduate student, this book was called, I think the title is A Handbook of Writing for the Mathematical Sciences. And the guidance in there that I loved was, if you can write it in maths, you ought to be able to say it in words. And when you described, Jonathan, the process of the logic that you've gone through, I followed it. You wanted to know that x was symmetric when it was equal to y plus z. Y wasn't, z wasn't, but you've been able to establish what wasn't symmetric about y, what wasn't symmetric about z, seen that they have offset each other. Symmetric plus symmetric on the right-hand side ended up being equal to symmetric on the left-hand side. Thank you very much, game over. It's somewhat irrelevant what the parts in the detail were of what was symmetric or not symmetric about the y and z elements for the logical understanding of what you've done. So why do we put so much emphasis on those details? Is this an exercise in in making it look harder so that it looks more impressive at times?
Oh no, the details are really important because we have to understand them so that we can generalize them.
So I'm laughing because everyone says that.
They are important. Devil is in the details.
Okay, but in a sense, to understand the detail, you have to understand the pathway that you're following. So is the detail masking the pathway, or is the pathway illuminating the detail?
They are shining light upon each other, if I can say that to a blind person.
Yeah, I think this is where when we proceed, we have to be very careful when we fall into reductionism. Because if we say this aspect is significant, that doesn't mean that the details are not valuable. But I think Dr. Godfrey was lifting up something that Dr. Fine said very cogently and clearly using natural language. You know, the residual symmetry is also the residuals that were not symmetrical combined to form something that was symmetrical. That's significant, but didn't require the details. And at the same time, that doesn't reduce the significance or importance of the details themselves, which are the technical underpinnings. And it seems to point to the fact that the way we understand something is kind of multidimensional.
In this specific case, what Jonathan Godfrey called the details is that these two asymmetric things combine to give something that is symmetric. And that's a fairly deep result, or it's a sort of piece of magic, if you like. It's certainly magic at the moment because I don't understand why it's true. If I understood why it's true, I could prove it for higher order.
That crops up so often in theoretical physics, Jonathan. I'm laughing. Yeah. We're all laughing.
So the so I didn't understand. It was only as I was writing it up and trying to make it clear that I understood something a little bit mysterious and special was happening. It was only by sort of breaking it into parts in a particular way that I saw that one thing was quite bright and shiny and had an odd looking thing sticking out of it, and the other thing was bright and shiny and had an odd looking thing sticking out of it. And what do you know, they fitted together to make something else that was bright and shiny. And that's absolutely